So at the end of that design stage, the structural engineer issued their 2D, they were working in 3D, but they provided their 2D concrete lift core wall drawings. So that's what you can see on the left there. That's an example of one of the sections of the lift core walls. And when they issued this, they said it was ready for construction and that all of the penetrations had been coordinated with the architects and MEP teams. So what we did with the contractors, we went through a process of 3D clash detection, and we identified multiple clashes where there was main MEP services going through that core wall that wasn't incorporated on the drawings with a corresponding penetration. So on the right side, you can see some more of the penetrations have been added. We went through this process of clash detecting, finding the issues, and then to resolve the issues, we got the structural engineer to design and incorporate an opening. So these blow-ups just show in a little bit more detail the two areas that sort of demonstrate the difference. So as you can see on the left, this was the end of design stage drawing, and then on the right, this was a blow-up of the revised drawing once we went through that process of clash detection. And as you can see, it's almost, like a Swiss cheese on the right in terms of additional penetrations. And all of these items were needed. The MEP system needed to get into the risers through that core wall. So if these walls had been built without those penetrations, the cost of post drilling and post breaking out these openings would have been enormous. However, we're doing it in a process of clash detection. This process was, a lot more of a cost saving, and it avoided the contractor being using their builder's work in connection budget as well. And it demonstrates how BIM can be used to identify those issues and then resolve them and make sure that the whole the building is more buildable for both the trade working at the time, but then all of the follow-on trades as well.